Okay, we will get started. Okay, it's almost noontime. First, I would like to welcome all of you to come to this lab and discussion session. My name is Dr. Eric Chou, CHOU. Okay, some people pronounce as Chu, some people pronounce as Chou, but I'm okay. Either way, okay. You call me Dr. Chu, I'm okay. And actually, if you know that there are a lot of people actually from Hong Kong, actually they are CHOW. Okay, from China they are GHOW. This is actually one same last name. Okay, I would say that worldwide probably more than 50 millions of people sharing the same Chinese last name. Okay, a lot of people actually. Number 9, number 10, largest family name in the whole China. Okay, but I'm not born in China. I'm born in Taiwan. Okay, and my hometown is located at Hsinchu Scientific Park. So if you know about TSMC, Taiwan Semiconductor Manufacturing Corp. Okay, it's a very high tech location, and I was born there, and I actually went to the National Taiwan University to study computer science and electrical engineering and computer engineering. And then later, I went to USC, okay, for my master and PhD degree. So I finished my PhD at USC, and I'm currently a IEEE senior member and also teaching classes and running my own company. Okay, this is my show introduction. So this is my name, and I have roughly maybe 10 different patent, US patent, and maybe 20 something publication. Okay. Okay. First, that's my show introduction and my resume. Second is the textbook. Okay. We are going to use this textbook called Robotics Modeling, Planning, and Control. So this one, if you need a PDF, I do have a PDF. Okay. I do have a PDF. Is this book very useful? I would say it's a good reference book. So if you need that, I have a PDF. I can keep a PDF link to you, okay, or sharing the PDF. So this one actually, why we pick this book is because that this is a graduate course. So we focus more on the modeling, okay, planning and control of robotics. Okay, so robotics actually is a very big field, and it's very important. And you learn the robotics, you will be able to use it in many different applications. Okay, let me explain the computer science and the computer engineering data field. Okay, so when you get started for computer science, the first thing you learn is the programming skill. Okay, so programming skill, you learn C++, you learn Java, you learn Python, different languages. So first thing is your programming skill. Let's put it as a PS, okay? And then after that, you learn some core computer science knowledge, such as computer architecture, data structure, algorithms, and the programming language, and the networking, and database, and AI. Okay, those are CS core courses. And you become CS major. Okay, you become a CS major. Okay, then we hear about the word data science. So data science would be programming skill plus statistic. Okay, that's data science. So use the statistic to analyze the data, and you need to have some programming skill. Okay, that's data science. And then next one would be machine learning. Okay, machine learning. So machine learning is data science, and then again plus optimization. So you're not only using the statistic, but you also need to solve the optimization problem. Using what for optimization? Using past historical data. Okay, using past historical data to do optimization. That become your machine learning. Okay, so machine learning is data science. You analyze the past historical data to build up your learning model. Yes, question. If you have question, you can interrupt. Okay, during my talk. Okay. Hi. How are you? Okay. There's no. So during my talk, if you have question, you can switch on your microphone. You can just directly ask question. Okay. I'm okay to be interrupted. But if you are not talking, I suggest to mute your microphone. It's okay? Hello? It's okay? We do have Nick. We do have Ifani. Okay. I'm sorry if I pronounce it in the wrong way. Okay. Any question?
Okay.
Okay. Okay. Let's continue. Okay. So machine learning is like that. Okay. The machine learning is data science plus optimization. And then next one is deep learning. Okay, this one is deep learning. So next one is deep learning. Okay, so deep learning is machine learning plus neural network. Okay, so you would use a neural network to do learning, and that's a special learning way. It's still it's one kind of machine learning and doing classification, clustering, pattern recognition. Those are actually deep learning. Okay. And next one is AI. AI is deep learning plus domain knowledge. So you need to apply your knowledge for deep learning into the natural language processing or business decision or any pattern recognition, right? Speech recognition, all kinds of things. That's called AI. So you need to have the you need to have the domain knowledge and your deep learning knowledge. Okay. So that AI, and now next one is robotics. So robotics, you need to have a sensor, you need to have actuator, and then you also need to have the feedback system. So you do have the AI. So you have the AI plus your sensor actuator. So it actually is robotics is AI plus mechanics. Okay, you also need to know about mechanical engineering. Okay, that's your robotics. So actually, robotics is including a lot of skills. Okay, including a lot of skills. It's a very big field. Okay, this field is very big. So we focus on modeling and planning. Okay, because there are so much things that we need to learn, and we more focus on the model mathematical aspect of it, because we are an online course. So it's very difficult for us to really work on the lab work. Okay. So I'm sorry for that, because this is an online course. But you need to know that the technique you learn from here will be able to apply to many of the fields that you will talk about. And the next one is the autopiloting drone. Okay. So autopilot drone or autopiloting is robotics. And then you also have the aerospace engineering technology, that even more advanced. Okay, so we do see the Ukraine-Russian war that drone is very, very useful. Okay, so these are the things that if you get involved in modern day computer science, there are so many things you can learn. Okay, so many things you can learn. Okay, so that's about the field of the robotics. And we are teaching you the core knowledge using modeling, planning, and control. And this book is written by 3 professors in Italy. Okay, so they have a lab over there. Okay, you can check this Prisma lab. Okay, you can check their information. But anyway, the syllabus. So the syllabus we actually we will not be able to cover every type of robot. There are so many, but our main issue is to talk about the computing aspect. Okay, the control planning and control side of the story. So we first need to know about the controlling model. Okay, so the textbook has many chapters. So we will cover the chapter 1 introduction. Okay. And then after that, there are a few things. Look at this simple diagram for the robot. Okay, you do have an actuator, you do have sensor, you do have manipulator. So usually robot arm is the manipulator. Okay, something that take action is the manipulator. And we do have the sensor take the feedback, and the feedback compared with the trajectory planner, and this form a feedback loop. Okay, so it actually is a feedback loop. So our overall view will be such a mathematical model. Okay, such a mathematical model. So the different chapters, say we started from chapter 1 as introduction, right? And then we talk about how to operate the manipulator. So it included chapter 2, 3, and 7. These are different things over there. Okay, that's the manipulator. And then we may talk about the sensor, the actuator, and control structure. Okay, and then feedback, and then the control part. Okay, and then the trajectory planners. So that's the overall mathematical aspect of a robot. Okay, and again, these are different knowledge you can apply to many other fields. Okay, so the first thing is that I would like to clarify the grading. Okay, so you do see there is a course shell. We do have weekly. We have many assignment, quiz, everything. Okay, so everyone you will get some point. Okay, everyone will get some point, and at the end we sum up all the point divided by the total point. I mean, using the point that you earn divided by the total point that we have in the class, and then using the percentage to decide your final grade. Is that okay? And the breakdown of the here we do have this syllabus. Here we do have this syllabus. So basically some quiz, we have certain point, okay, assignment, there are certain point. I would say usually the quiz is more difficult, okay? So be careful about this part. And then we do have finally we do have some extra point I will assign to you. And it will depend, okay? This extra point actually depends on the whole class attendance record and also discussion involvement and many things. And basically this one is for me to curve the student up. Okay, so basically you will get some certain point. Say if all of the assignment you achieve, okay, all the assignment you have done here, it will be 900 plus 1200 plus 200 plus 600. So this one I think is 2900. Okay, so here we do have 300 points. So overall, the total number of points you may earn will be 3200, right? But we will not use the 3200 as the divisor. Okay, we will use the base point 2900 as a divisor. So your total number of points may be more than that. Then you got an 8. Okay, is that okay? So this one actually usually the extra point will be curving point. In case that you are not good here, okay, you have some problem, we can curve you up. Is that okay? Hello, is that okay? So the base point, the divisor only use the base point here, okay, whatever the sum of every assignment. But the extra 300 points will give you to curve up the whole class. And how much point I will curve depends, okay. Usually, it depends on whether this class is actually really do spend time to work on it or not. Okay, is that okay? Hello, is that okay?
Yes, Professor.
Okay, so try your best. Okay, try your best. So this one is about so what kind of knowledge you need? You probably need some basically Python language is a must. Okay, you must know about Python language. And you must know about some linear algebra, okay? Some linear algebra, and also using some math, okay? Some math you must have, okay? Other than that, you need to know about the robotic models. Okay, so these are actually rough, my overview of this course. Any questions so far? No question. And then if no question, we go over this course course syllabus. So every Tuesday and Friday, I do have this lab and discussion. So you can come over if you want to ask question. You can come over every Tuesday and Friday. Okay, if you do have some issue that's urgent, you can reach me by phone or you can reach me by Facebook. Okay, my Facebook account is pretty simple. You just okay. Let me try to use the using this browser. You just type HTTP, okay, and then Facebook.com/dr Dr. Okay, Dr. Eric Chow. Okay, so that will reach my Facebook page. Okay, I would reach my Facebook page. So you become a friend and send me some sort of message. I'll reply you. I'll try my best to reply within a day. Okay. So this web page is pretty simple. You just type HTTP. Okay, Facebook. If you want to send me the email, it is okay, but it may take longer time. Okay, I do not read Louis' email every day. Okay, I do not. Okay, I'm sorry. Okay, just type these. Okay, Facebook.com/dr Eric Chia. Okay, and I have HR email actually that is. I have another Gmail that is ECHOU510@gmail.com. I read this email more than the Louis email. Okay. And 510 is my area code, so not really hard to remember. Okay. 510 is Fremont's area code. And my email at Louis is ECHOU@louisu.edu. The same as everybody else, okay? But it's easy for Eric and something like that, okay? But usually I would say email, I'll definitely read it every day. Facebook would be faster, okay? The school email, I sometimes not reading it every day, okay? Because I'm not a full-time professor on campus. Is that okay so far? Okay, that's the way to reach me. And then if you prefer to call me, it's okay. My phone number is 510-304-9428. Call me is also okay. Text me is also okay. I'll take it, okay? Okay, these are the way to contact me, okay? And then go back to the shell. So the shell over here, every week the shell is well organized. So you do have some topic, okay, and then to do this, what you should do. So first thing you need to do is to go to this instruction material, okay. There are some reading materials talking about which chapter you need to read, okay, which chapter you need to read, and they are lectures. So lecture actually, you go to the lecture. They are video, okay. This video actually is being recorded in 2020. Okay, so you can watch the video here. Okay, so I do not teach again because this video already there, and so you just watch video and let me know if you do have some questions. So there are PDF you can download. Okay, this PDF you can download. It's actually at my GitHub site. Okay, the slides is all here. Okay, you can download. Okay. If it's just short, don't worry. Okay, you can have more page. You can still scroll down, and more page you can scroll down. And right here, you can download the PDF from here. You say download. You download to your local. Okay, you download this PDF to your local. Okay, so that's actually the PDF. So I do have sometimes the PDF, sometimes sample code. Okay, and then these are the pre-recorded videos. So the lecture are all here. Okay, you watch the lecture first, okay? And once you are done with this different one, and then you kind of, there's some extra reading material. And There are also some term project description you need to look at, okay? And then you work on a week 1 assignment, okay? So there are quizzes, there are programming assignments, there are discussion, okay? So usually, I don't deduct any point for discussion. So try to just discuss whatever you want to say, okay? And I may not reply because this is open discussion, okay? So when I grade, usually I will give the full score for this discussion portion, okay? So don't feel like, okay, I may get deduction for this, okay? Whatever you want to say, just say it, okay? So discussion portion, I usually will give you full point. And quiz are mostly auto graded. So you just will get point based on the multiple choice. So it is auto graded. And I will grade the programming assignment, okay, every week, okay. But if you are late, okay, what happens if you are late? If you are late in submission of the programming assignment, I will still take it, okay? So you please try your best to submit as many as possible and as early as possible. So, but if you are late by too much, okay, by too much, you may get deduction, but I will still take it, okay? I'll still take it. But when will be the deadline, okay? When will be the deadline? So you may be late 1 week, 2 weeks is okay, but week 8, okay, let's assume that we are at the week 8. At the week 8, Friday, Saturday, we are done with the course, right? So I would take if the Friday is the last day of the class, right? I believe this year is December 17, okay, maybe Saturday, okay, maybe Saturday. So I would take whatever submission before 11:59 p.m. Okay, 11:59 p.m. of the Sunday up to the last day of the class. Okay, the Sunday midnight, before the Sunday midnight of the last Friday class. Okay, that's the real time that I will cut off. Any submission up to that, I will not take it. I will not, because usually I need a Monday to tabulate your final grade and submit the score to the university, okay? And usually it's due on Tuesday morning, 8 o'clock. Okay, so I do need 1 day to do it. Is that okay? So I use this time, usually I use the Sunday 11:59. Okay, if you pass it, I don't take it. Okay, don't tell me that I still want to submit. I don't take any extra submission after the time. But anything before it, I will take it. Is that okay? Any question? Is that clear enough? Okay, that's about the time. So let's look at this. Okay, yes, question? So this year, I think December 18 is the Sunday. Okay, so the 11:59 p.m. of the Sunday Central Time, because some people are in different time zones. So we use the Central Time as the due time. Okay, so Central Time 11:59 of the Sunday, December 18. Okay, that's the cutoff time. Any submission after that will not be taken. Any submission before it will be counted. Okay. Any question? No? No question? Okay. Next one, they are recorded sessions. So here we do have every year's pickup. Okay. So I would say 2020, we do have everything recorded this year. Okay, everything recorded. So the full version of the lecture is over here. And then every year we have the discussion, video being recorded, put there here. Okay, so if you are interested, you can go there to look at it. Okay, the previous years of discussion or whatever. Okay, and some of the good term project are also included. So, for example, that the term project, let's actually look at this one. There is a toilet robot. Okay.
Okay, here is my final project. It is the toilet robot. It is a robot that is designed to play music while you are using the toilet, as well as close the lid when you are finished using the toilet. And so before I plug it in and show you how it works, I want to talk about a design philosophy that I use. Because a lot of things are going to happen when I plug it in. So I like to check everything is working and let the user know that everything's good before it actually starts anything. So what we're going to see, it's going to be difficult to catch, but these two lights are going to turn on to show that they're functional. This music is going to play. And this servo down here is going to engage and set its position to 0 degrees. And so,
okay, so this is a project, okay, and let me fast forward to some location, okay. So he introduced how his detector work, okay, and then he actually eventually put it in the working environment that he want to achieve, okay. But anyway, whatever project will be acceptable as long as it's a robotic project, it will be acceptable, okay? And you apply the knowledge you learn from the course, it will be very much welcome, okay? So try anything that you believe that you can try, okay? There's no limit as which kind of project you should do and which one you should not do, as long as it's related to robotics, okay? Related to robotics. So every student's project may be quite different, okay? Maybe quite different. So some are really more difficult. And he doesn't build robot, but he actually work on such robotic arm modeling using some, I think this one is Blender 3D, okay? Blender 3D, we use that to do programming. That's even fine, okay? That's even fine. We take the modeling, we also take the robot, real robot, okay? So that actually is a good plus if you actually can work on something like that, okay? So different year, they are the robot project. So the project, you can start to think about it right now, okay? You can start to think about whatever you want to do, experiment, but don't try something too big, okay? Something too big, you cannot finish that. Then that doesn't make sense, okay? And anything, someone who actually bought some high-end robot and he try to control it, that's actually fine. Okay, some just do mathematical modeling, that's also fine because everybody's budget is different, okay? So try your best, whatever you want to do, okay? And then we do have a proposal that you need to work on, okay? Then the proposal just would like to look at your planning. Okay, so week 3 we do have a term project proposal that you can work on, and this term project proposal actually is to ask you to work on a proposal. Let's assume that you are working for a company, right? And you are asking for money from your manager or some approval from your manager. Then you need to prepare your proposal. Okay. So you need to have some write-up such as PDF or Word file or Google Doc sheet, okay, whatever you can use to write down your project description. And the basic thing is that you need to talk about a deliverable, what you want to deliver, and how much time you want to spend, and methodology you want to use, a tool, a material you want to use, okay? Write it up as a proposal because you need to try to learn how to write proposal, even if you later try to find a job in the industry, okay? And they need you to write proposal. You need to just assuming that this one is actually a job preparation project. So you need to write the proposal and make sure that your funding agent, your company is willing to give you the money. Okay, so this one is why we want you to write a term project proposal. Okay, so this one you focus on what do you plan to do, okay? What do you plan to do? And later, this one's in week 3. In week A, when you are done with the whole course, the term project is due. Okay, so this one is different from the proposal. Proposal, you don't have anything. But term project, when it is due, you need to write up your result for your term project. Okay, so this one, we don't need too much planning portion. I don't need the planning. Just talk about what you have done, what and how you did it. Okay, and if you can prepare the video like the previous student, that would be a good plus. And if you cannot, at least one write-up, say one Word file, one PowerPoint. Write-up is the report. Okay, you need to write it in the full technical report format. And then presentation, I take a video link, say YouTube link or PowerPoint or Google Slides. If you can make video, it's better. Just give me the video link. Okay, so I do not need you to send me the MP4 file, okay, or MP3 file. I don't need that. Okay, I just need you to send me, okay, HTTP, okay, and then YouTube. Okay, .com/xyz12345. Okay, whatever your link is. I just need that. Okay, I just need that to actually look at that, how much you have done it. Okay, so presentation can be done either by PowerPoint or by video. One of it is okay, but if you do both, that's also welcome. Okay, if you do both the PowerPoint and YouTube, is also welcome. But in addition to that, you also need to have a final report. But this one, we want you to write it in the full technical report format. So that is also a preparation of for your job. Okay, and then that's the 2 items you need to report. And also, if you can send me the technical files such as Python programs, design schematic file, or AutoCAD file, that's also welcome. Okay, so 3 things you need to submit at the final report, okay, including the technical write-up, 1 presentation file or link, and technical file. Okay, any question? Hello, any question?
No.
No question. Okay, and other than that, you just follow every week's requirement to do it. Okay, and can you submit the homework before it's due? Okay, it's very much welcome. Okay, very much welcome. There are some students who finish every homework just in week 3 or week 4 before. Is that okay? Yes, they are welcome. Okay, as long as you watch the video and you do study the course material, it's okay. I don't limit you to submit everything in week 8. Okay, no, or just on the week. Okay, whichever week it is. You do not need to wait for week 1 to submit week 1. You do not need to wait for week 4 to submit week 4. No, anytime you submit in advance, that's actually okay. Because we are an online course, I would like to give you the maximum flexibility to do it. Okay. But try not to do this, okay? Try not to pile up everything until week 8, okay? Because we have many things to do. So if you pile up everything until the last week, I guarantee you cannot finish, okay? You cannot finish. And also the term project, I would like you to start as soon as possible. Do not wait until week 7 to start your term project. That will also be too late. Okay, that will also be too late. So don't pile up things, and then if possible, start everything as early as possible. Okay. Any question? Okay, so this Tuesday and Friday discussion is used to communicate. So if you have any question, you are welcome to ask question. If you have some problem, you are welcome to ask question. Okay, but some question I don't answer. Okay, I have to make it clear. Some answer a question I don't answer. The questions such as where can I find the answer for question 5? Okay, there are some students who just want to know about the answer and in which page of certain book. Okay, that's not my responsibility to teach you how to find the answer. You study, you need to figure it out. Okay, so don't ask me like, okay, question 5, which page should can I find the answer? Okay, I don't do that. Okay, I don't give you the. You can discuss the theory, you can discuss the how it works. Okay, or something you don't know, but don't ask me like, okay, question 5, what is the answer and where can I find the answer? And that's not a kind of question a student should ask, right? That's your own responsibility to study, right? So those kind of student question I don't ask, okay? And another kind of question I don't answer is some student ask me, would I get the full score on programming assignment 1, 2, or 3? That I don't answer the question like that, okay? You just do your best. You just perform your best, okay? And whether you get full score or not, I will grade it and you can see it, right? So I don't actually answer those kind of questions that how can you get the full score. And in the past, I'm not kidding. In the past, some programming assignment is 100, but I do give 120 before, okay? So I may not use a subjective score grading. I may actually be additive. I may add more point to you if you really outperform my expectation. Is that okay? Hello, is that okay? So try your very best. And if you outperform, you add more material, it's welcome. Okay. Okay. Don't just say, okay, I just meet your minimum requirement. And then ask me the question like, okay, how much point can I earn if I do this and if I don't do that? Okay. We are not negotiating for point. I do encourage you to do whatever you can do. And if you do more than what I expect, then I may give you some extra point. Okay. Any question? Bottom line is that I encourage your self-motivation. Okay. I encourage your self-motivation. I don't encourage students to meet the minimum requirement of the assignment by the teacher. Okay. Is that okay? Okay. Still no question? Okay, so if still no question, let's do this, okay? Let's do this. If still no question, let's do this. That's actually, let me bring up the, usually in lecture 1, I would like to discuss this linear algebra, okay? So there's an appendix linear algebra, okay? So the whole course actually need a strong mathematical background, okay? So if you don't have question, I'd like to start with this linear algebra because in your chapter week 1 assignment, you will need that already, okay? Anybody has some trouble with Python language? Hello, anybody has issue with Python language? So if you do have the Python language problem or tool problem, I can help you to do installation, okay? Any question? No? No question? So make sure that you need to have something, okay? You need to have a few things that you need in the homework, okay? First thing you at least you will need Python compiler, okay? Python interpreter. You need Python interpreter. Second, you need to be able to use NumPy, SciPy, okay? Also, you need to use a matplotlib. Okay, these are two packages you will need it. Okay, if you don't know how to install it, I can teach you how to install it. Okay, I can teach you how to install them. And usually I also have some video. I can just send you the video to teach you how to install the software so that you can use them. Okay, so that you can use them. And then, so that's the first thing you need to check. You must have the Python interpreter and the tool package that we need. Okay, that we need. Otherwise, there are so many modeling problems we need to finish using programming. So you will have tough time. Okay, so if you do have some issue with these different with the Python tool, please let me know. Okay, please let me know. I'll help you to do installation on the tool and guide you a little bit. Okay. Any question? No. Still no. Okay. Still no. Let's actually get started with this linear algebra portion. So this week one homework, you will need this. Okay. You will need this linear algebra portion. So let's get started with this one. So first thing you must know about what's array, what's actually matrix, and being able to manipulate the matrix operation, because many of the operation in robotics are in the matrix or in the vector format. So you must know what is scalar, what is vector, what is array, what is matrix. Tensor, we do not require it, but it's good if you try to know it, okay? Because right now, a lot of the AI use tensor, okay? And because we are doing modeling and control robot, so this different thing is really important, because every robot operation are modeled in metric format. Okay, so this one is very important. So you need to first review your linear algebra knowledge. Okay, very basic one. We at least need you to do that. Okay, so this map probably is optional. This one is not must have. Okay, this one is not must have. But it's good to have if you know how to use the probably for graphing tool. And here, more important part is you must be able to use a NumPy, SciPy, and Matplotlib. Okay? And this project, if you don't know how to install them, I can teach you how to install them. Okay. Next one is array. Okay, array. You must know what is array. So before you know array, you must know what is scalar, vector, matrix, and tensor. So a single data, we call it scalar, right? Scalar. Two or more data in a linear structure, we call it a vector. Right? Two-dimensional data, we call it a matrix. Okay. And multiple dimensional data, 3D or more, we call it tensor. Okay. But in fact, this word tensor including the matrix and the vector as well. Okay. But usually when people talk about tensor, it's 3D or more, we call it tensor. 2D, we call it matrix. And actually 1D, we call it vector. But tensor can be a generic term, including the vector and matrix. Okay. It's any dimension is called tensor. So Google do have a tensor processor. Okay. But what? And NVIDIA have the so-called graphic processing unit operating on matrix. Okay, so these are the AI processors, and CUDA tool by the NVIDIA is a very important AI tool. Okay, so here this course we primarily working on matrix and the vector. Okay, we need to work on this intensively. Okay, that's the data. Okay, so you need to know about NumPy array, and you also need to know about the list in the generic Python. Okay, in the generic Python. So let's get started with this one. So first thing is that you must have your environment set up. Okay. So for me, I will use the Visual Studio Code. Okay, you need to install the Visual Studio Code or some editor as well. Again, if you don't know how to do it, I can teach you. Okay, I can teach you how to do it. You must let me know. Okay. Okay, so here I'm going to find a directory. So here I find a directory. Okay, so here I'm going to look at this one. So I'm going to work on the appendix. Okay, first you need to install your software, but here we don't repeat to teach you how to install. If you have question, I'll tell you. And I use a window R. You bring up the runner and I type in CMD. Okay, you bring up the command line. Okay, you bring up the command line, and then I do left click and copy this address, come back to here, CD to that directory. Okay, so that would switch to here using my DOS prompt. I usually start from here, use call that. Okay, you can start your Visual Studio Code in Windows and then change your folder, but usually I do this. Okay, I do this using my DOS prompt to bring up my Visual Studio Code. And this that means the current directory. So you will bring up the Visual Studio Code for the, using current directory as a folder. Okay. So it's coming up. Okay, so here is coming up, but you need to really install your Python interpreter and also the so-called NumPy, SciPy things. Okay, so let's get started here. If I actually have the first program called test that py, okay, it's a py. So here I do from, okay, pilot. Wait. Here I do from pilot import start, okay. PyLab is Python lab, okay. It's similar to MATLAB, okay. I use Python because of this. It's a free MATLAB we can have, okay. We do not need to pay any money. And PyLab actually included NumPy and Matplotlib, okay. NumPy, numerical Python, okay, NumPy. Some people pronounce NuPy, okay, whatever. And it's called NUMPY. I think it's numerical Python, okay. So, okay. And then another one is Matplotlib, okay. It's a metric protein library, okay. So these two tools you need it, okay. But PyLab including these two tools, NumPy and Matplotlib, okay. So you need that. You need that to get started. Okay, let's assume that we do have a list. Okay, let's actually get started with this one. Let's actually have a X. Okay, this X I say it actually is a linear space. Linear space is it actually is a function in NumPy. Okay, so here you say it's from minus 6.28 to 6.28. Okay, it's from minus 2 pi to 2 pi. And then 101 point, okay, and then my y would be equals to, okay, a sine, okay, here I do sine of the t, okay, I don't see the sine function, okay, so here I say import NumPy as NP, okay, import NumPy as NP, so NP is a package, so NP dot sine, okay, and then for t in x, okay. So these two create what? Create x and y, okay. So your x is like this. You do have a line, that's x. You do have another line, that's y, okay. And each data point here, you have a t. So each t, you get a sine t, okay. And I'm going to try to plot this one, okay. Try to plot the sine wave. So I create, so this one is a parametric function, okay? Your x is t, using t is time, right? Time. And y is, for every t in x, you get its NumPy dot sine, okay? With this tool, I can do figure, okay? And I do show at the end. And between, I do say plot my x and y, and then in green color, okay? So this one is a very simple tester, making sure that your environment works, okay? And then I say run code. Run code, you need to install a run code is plugged in. Okay. And this one is a sine wave. Okay. Any question? Okay, so this one is a demonstration of your numerical package is working. Okay, this one is a demonstration of your numerical package is working. So here, I do try to use PyLab and NumPy for it. Okay, so that's that. Now we go back to our array. Okay, we go back to our array. So our array is a one-dimensional representation for data. Okay, sometimes it's array, sometimes it's vector, sometimes it's actually list. Okay. The difference between array and list is array is fixed size, so you cannot grow or shrink the data. Okay. List you have you can actually grow or shrink in the data. Okay. So sometimes you need to convert between list and array, back and forth, back and forth. Okay. So list is actually of flexible length. Array is a fixed length, okay? But this actually usually is slower because these have extra operation on it, okay? Array actually is faster. It actually can be compared to C-level array, so it's faster, okay? But we do need to use a NumPy array and list from time to time, okay? So that's the representation for one-dimensional data. And here you can create a array using this one, okay? And you can find the maximum using the max function, okay? This one, let's try this one. So first thing, let's actually do array number 1, okay? Python, generic Python language do not have array. It's called list, okay? So here I have a list equal to 1, 2, 3, okay? So list is actually like this, okay? And then I can do print, okay, a list, okay? I'm sorry, print a list. This is a generic list, okay? And I can actually run code to get it. Okay, so the data here, 1, 2, 3 is over here. Okay, that's actually a list. Okay, a list you can actually add data or remove data. Okay, so you can add data or remove data. So you can do actually do a list that append 4. Okay, and append 4 will append the data at the end, and let's actually look at it. So when I do append 4, and then my list become 1, 2, 3, 4. Okay, my list become 1, 2, 3, 4. So you can append something to there. Okay, and you can also do this the pop. Pop will be removing some data. Okay, so after you pop, the number 4 being taken out. Okay, after you pop, the number 4 being taken out. Okay, you can also pop some index. Say I pop this 2 out. 2 is at the index 1, so I say a list pop 1. Okay, that one is index. So let's print a list. Okay, and you run it. So that actually is the index 1 location of 2 being deleted. Okay, so for any other operation for list, you have to study. Okay, you have to study. Right here, I just give you some basic idea of what it is. Okay, so let's look at another one called array1.py. Okay, this one actually is the array. Okay, so first one, I do have a list. Now this list, I would like to convert it to a array. Okay, hello, how are you? Okay, so let's actually pass it over here. I do have an a list. Now I use a array. Okay, ARR. Okay, so this ARR, I say I would like to convert it to array. But this one, generic Python do not have array. So here I need to do this. I need to do import. Okay, NumPy. Okay, some people pronounce it numpy. It's okay. I always pronounce it as numpy. Okay, so numpy is in np.array. Okay, you load your array list to this. Okay, after that you do print. Okay, print type of the ARR. Okay, let's look at the type of this ARR. So after that, you actually become numpy array. Okay, it become numpy array, and then we can do print ARR. So we print ARR. This one is a array. Okay, this one is an array. So you see, array there's no comma. There's no comma. Okay, it's an array format. It looks like a vector now. It's different from the list we have. List is a 1 comma 2 comma 3 comma. Okay, so this one is the printout format for list, and the array do not have the comma. Okay, any question? Okay, but this array we can convert it back to a list. Okay, so let's call it b list equal to list, and we convert it from using the ARR, using the numpy array to convert it. So this one we convert back to a list. Okay, and again, let's put in the type of the B list. Okay, that you will get the list type. Okay, okay, it say that it's actually this type. Okay, and one way to quickly understand the so-called Python's data structure is Python do have double quote, that's actually string. Okay, double quote is string. Single quote, parenthesis, this one is called tuples. Okay, tuples. And then break it, this one is list. Okay, and curly brace, this one is set. Okay, and then curly brace A:3, comma B, okay, this 4. Okay, this one actually is dictionary. A dictionary in other language, we call it map. Okay, so you must know all of these. Okay, if you do Python programming, you need to know all of these different compound data type. Okay, you need to know about these different compound data type. And then one of them, this list, is similar to array list in Java language. Okay, and it can be converted to the array. Okay, and array is numpy's array. Okay, so that's what we have done so far. So you convert it to numpy array using np array constructor to build it. When you convert it back, you use this function to convert it back to the list. Okay, so these are different data structure that we commonly use in Python language. Okay. Okay, so that's something you need to know for as a review. Okay, so here I just talk about it this way, and there's a maximum function you can do to get the maximum. So each array you do have the dimension. You call ndim. Okay, n dimension. Ndim is the dimension, and then shape, size, these different things. Okay, so let's look at this one. So this one is actually create another one. This one called array 2. Okay. I'm sorry. Let me create this one. Okay. Let's call it array 2. Okay. So sometimes you can create a matrix. Okay. Here let's actually do import. Okay. Numpy as np. Okay. So now I need to have two-dimensional matrix. Okay, two-dimensional matrix. So I say here, let's do m. M equals np dot nd array. Okay. Okay, this one I create this one, and here I would like to have two-dimensional array. So it actually let's create something like this. Okay, list in list. Okay. So here 1, 2, okay, 3, 4, okay. So this one I just try to break down so you understand that this one is a two-dimensional array. Okay, you use an ND array to do it. Okay, so after that you do print your n. This one create a two-dimensional array. That's actually a matrix. Okay. Three, four cannot be interpreted as an integer. Let me see, 3, 4. Okay, let me use a ND array. Okay, let me use array. Okay, so this is a two-dimensional matrix. Okay, not ND array. Use this one. This is a two-dimensional array. Any question? It's a matrix. Okay, this one is create a matrix. Okay, so that's a two-dimensional array. And sometimes you can load it as a single 1D, but you reshape it. Okay, so reshape it based on your row and column. You can reshape it in different way. Okay, so let's try this reshape now. Okay, so here let's actually try to have a equals np dot array. Okay, here let's put in 1, 2, 3, 4, 5, 6, 7, 8, 8 element. Okay, so A is an 8 element array. Okay, and A equals A dot reshape. Okay, let's actually print it first, and then let's reshape it to 2 by 4. Okay, and let's print A again, and then let's actually do A equals A dot reshape, and then 4 by 2. Okay, and let's print it one more time. Okay, so reshape is that you can reorganize the data originally 1D to 2D, 2 by 4, or 4 by 2. Okay, you can actually reshape it in different format. Okay. Okay, so this one is 2 by 4, this one is 4 by 2. Okay. So that's actually is the function of reshape. Reshape is pretty important, especially you first load the data in one-dimensional format. And then after that, you do undim. Undim is a parameter, is a constant variable. So you can now look at this one. Okay, say print a dot n dimension. Okay, undim. Okay, that would be two dimension. Okay, and you also can get the size. Size is 6. Okay, you can print shape. Shape will be a tuple. This tuple is 2 tuple data. It has the 2 row, 3 column. Okay, that's your shape. So it's a basic array operations. Okay, these are the basic array operations. Okay, this one is a basic array operation. You can look at it. Okay, you can look at how to calculate. Okay, this one. Okay, this one. Let's look at finish this one. Next one. Let's look at the creation of array. You can create array. Okay, by fitting in the list for it. Okay, you can also create ones. You as 1, 3, 3 will actually create 3 number for it. Okay, you will create 3 number for it. Okay, you can using zeros. 0 will create 0. 0 will create 3 0 into the array. Okay, you can also use the random function or random int function to generate the arrays. Okay, so let's see. Here you can use a random int as well. Okay, and you can assign the size assignment over here. Okay, so let's look at this random one. Okay, okay, random function. So we need to use a numpy. Okay, numpy we import numpy as np. Okay, There are a few random number function. One is random function. Okay, the other one is random integer function. Okay, there's another one called a range function. Okay, I'm sorry, random range function. Random range function. So these are a few different functions you commonly use for random number. Okay, so first thing, let's try this one. Let's try D3. Okay, so D3 I'll use a numpy that zeros. Okay, zeros of 3, and I print my D3. Okay, save. That's wrong. It. So you create 3 zeros. Okay. And you can say O3. O3 is 1, 3. Okay, so let's do it. So it's MP that 1s, 3 ones, and then print O3. Okay. You get 3 ones. Okay. Now we may want to use a random number generator to generate. Okay. So let's call R3 equals numpy that randoms 3. Okay, let's look at this one. Okay, so this is 3. Well, this random will create 3 random number, and every number will be every number that you generate will be less than greater equal to 0, but it will be less than 1. Okay, is that okay? Is that okay? Okay, so we can also do this one. Okay, if you don't like this one, you can also use a different way to generate it. Okay, so for example, if I want to create a number that's from -3 to 3, but need to include in 3. Okay, need to include in 3. If I want to create a number that's from -3 to 3, but I need to include in 3. So this random number will not be able to generate. Okay, you will not be able to generate. So you need to have a different function that you can do it. Okay, so here let's do define a function called R. Okay, R is a function. This R function, you take the number start and end, the 2 number in. Okay, this 2 number in, and this 2 number you will generate a number that's between start and the end. Okay, and end. But you only have a random number that can generate from 0 to 1, but not including 1. So this one, how can you solve it? You actually can create a span. This span would be end minus start. Okay, that's how wide this one is. Okay, so here, but you still need to have another one. You need to have a error. This error is use E1 minus 9. Okay, that's a small error number. Let's call it small e. Okay, let's call it small e. So e is a small error number. Okay, so that small number has some use. Okay, so right here I'm saying that I'm trying to do this. I create an x. This x is actually using numpy the random. Okay, numpy the random. So numpy the random function is generated a random number times span. With a span, it will generate originally random function will generate from 0, okay, to 1, but right now it will generate from this one. You will generate from 0 to span, okay, to span. But this is not good. Okay, this is not good because it's not including span. So here I plus the small e to there. and this one will be less than span plus E. So you'll be over the span. It will be over the span. Okay, and I'm going to actually press the star. After you press the star, you will actually starting from star, okay, and then ending at the end plus E. Okay, it will be in this range. Okay, you will be in this range. So after that, actually you do this. Okay, while the x less than E and D. Okay, you do this. Okay, so here when you get out of the while loop, you will have an exit condition that will give you x greater equals. I'm sorry. Here that's actually when x actually is greater than end. Okay, so when you get out of here, it will give you a condition of x will be less than equal to end. Okay, if not, you get a new one. Okay, you get a new one. Until when you get out of while loop, you will guarantee the number will be less than E. Okay, and that's the x you want to have. So here that's return x. Okay, so this one will generate the x between star and end, including the end. Okay. Okay, so that's the generation of the Rx. So right here, let's actually create another one. Let's actually call it R32. Okay, this one will be using the NP dot array. Okay, we will have a list. This list will do this one. We will have we will create this one Rs. Okay. Okay, we will create Rs minus 3 to 3. Okay, that's one copy. Okay, and then Rs. Okay, so this one we will do for T in range 3. Okay, so we run this one for 3 times, and every time we generate a number between 3 and minus 3. Okay, and then we put in this one called R32. Okay, so that will generate 3 random number between minus 3 to 3. Okay, and this one, if that has a problem, okay, module object is not callable. Okay, let's actually try this one. Okay, it's actually random. Okay, let's call this one. Okay, so it generates 3 number between minus 3 and 3. Okay, any questions so far? So random function is used to generate a number between 0 and 1. But we can actually write a function that will allow you to include in the ending one. Okay, that's a function we allow you to include in an ending one. Usually it's easier to generate star but not including the ending. Okay, because you generate 0 to 1. Okay, using the random function. But if you want to generate including the star and including the end, then you need to use the small error term, so that you oversample it, and then if it's greater than the end, you get another one until it actually is smaller than or equal to end. And this number x, when you return, it will be guaranteed between starting number and ending number. Okay. Any questions so far? Raju, are you okay? Am I pronounced right? Any question? No question? Okay, so that's generating of the random function. There's another function is called random int, okay? And you can generate how many number and then the size, okay, the size. Okay, this one you can study it, okay? I don't do it more, okay? So that one is okay. It just generate different integers. Okay, there are several different functions that you can use, okay? And then here, this chart, okay? These charts are all of the data type that you can use in NumPy, okay? So including the integer, okay, character, floating point, and there are different number type that you can create, okay? Many of them is not supported by generic Python, okay, it's not. So next one, we will look at the array arithmetic. So when we have two array, and you are going to perform arithmetic on it. So when you have two array, you sum them together. This one is a vector addition, just like your A, B, okay, plus C, D, okay. You will create A plus C, comma B plus D. This is a vector addition, okay. This was a vector addition. When you have two arrays summed together, it's performing vector addition, okay? So minus the same is actually also vector addition. And this one, when you just have a time, it's a vector multiplication. So vector multiplication has another name, we call it inner product, okay? This one we also call it inner product. Okay, when you have A, B, okay, times C, D, okay, and you got this one equals A times C, comma B times D, okay. This one is called inner product, okay, inner product. Any question? Okay, division is also inner division, okay. You actually divide by its own one by one, okay. If you have a array times a number, that would be the same as you time the same number for them. So this one is array, is a vector times a scalar, okay. So just like you have a vector, you time A times. It's a scalar, so scalar times 2. Okay, so basically you have 3 times 1, 2. It will be the same as 3, 6. Okay, this is a so-called scalar times vector. Okay, and you put the A before or after the array, it will be the same. Okay, it will be the same. Okay, this one is called the so-called scalar multiplication. Okay. So here let's do arithmetic. Let's try this one. Okay. So let's do import NumPy as NP. Okay, import NumPy as NP. So here let's do let's have a v1 equals to v1 equals NumPy the sine and the cosine 30 degree, okay, comma NumPy the sine 30 degree, okay. So this one is a 30 degree, but we need to convert it to radian scale, okay. So we need to convert it to radian scale. So here, okay, here again, your NumPy, okay, NumPy conversion to radian scale, okay. So the function called radians. So degree to radian is num-p degree to radian. You can convert a degree to radian. Okay, so convert angle to radian from radian to degree, and this one you can degree to radian. Okay, so that's called degree to radian. So this one is num-p dot degree. Okay, let's actually do A30. A30 equal to num-p dot degree to radian of 30. Okay, so that actually is A30. Okay, A is angle, A30, A30. Okay, and let's have another one called A40. A40 is angle, A degree to radian. Okay, this one is use 45. Okay, 45. Let's use this 45. Okay, so 45. So we do have a vector 2. So vector 2 equals to this one. Num-p the cosines A40 by num-p the sine. Okay, A45. Okay, so these are two vectors. One is a 30-degree vector. Okay, one is a 30-degree vector. The other one is a 45-degree vector. Okay, and we do inner product for it. Okay, we do inner product for it. So let's do this one. P, okay, V12, it will be product 1, 2, it will be V1 times V2. And let's pull in the P12, okay? Oh, I'm sorry. This one I need to do num-p the array. Okay, I need to convert it to array, okay? Otherwise, you cannot get the vector operation. Sorry. So num-p the array, okay? List cannot be used for the vector operation. Okay, so let's try this one. Okay, you got this. Okay, you got this. That's the inner product for it. Okay, and two vector you got inner product. V1 inner product V2 will be equal to what? Your U1. Okay. Let's see. I'm sorry. Time cosine theta. Okay, I'm sorry. This one actually is you take in the length of this one. If you do have the V1 inner product V2, this one would be V1's length times V2's length times the cosine theta. Theta is the angle between the V1 and V2. Okay, it's something like that. So this one is that. Okay, this one actually is would be the product, the inner product. Okay, and you can do indexing just like what you do in the list. Okay, you can do slicing. Okay, you can do slicing. Okay, you can also do slicing. Okay, now the slicing rule is slicing rule. Okay, let's look at slicing rule. When you have array, you try to do slicing rule. Let's assume that we do have a array A. Okay, let's do V. Okay, let's do V. So this V is a num-p dot array. Okay, here let's actually put in some number 0, 1, 2, 3, 4, 5, 6, 7. Okay. When you do slicing, there are three numbers. Okay, there are three numbers. Okay, so usually it actually has slicing. Slicing, you have the starting index, ending index, and the jumping index. Okay, so you have three numbers. Okay, three numbers. So let's actually print this one. print, okay, V, okay, nothing, okay, nothing, you will get V of from 0 to the length of the V and then jump by 1. These are the default value if you don't specify anything. So this one will be the same as you do print out V. Okay, it's the same. Okay, it's 1, 2, 3, 4, 5, 6. Okay, so let's try this one. Let's actually try V slicing. Okay, so the first one, if you don't put anything, okay, and the last one you don't put anything, so V to 3. This really means that you are starting from 0 to 3, okay, to 3. You are slicing 0 to 3, okay. So here you do print V, okay, colon 3, okay. The missing one will be 0. It's the default value of here, okay. That's the starting index you get when you do slicing, okay. So you get this, okay. The 3 is not included. 3 is not included. So ending one is not included, okay. Ending one. N is ending index element will not be included. Okay, so it's only 0, 1, 2. Okay, it's only 0, 1, 2. Yes. 3 is not included. Okay. Is that okay?
Yes.
Now, if I want to reverse it, how can I do reverse it? How can I do reverse it?
Print V bracket 3 colon 0 or 3 colon blank.
No.
Oh.
Here you have 0 to 7. You want to reverse this one, right? So it's starting from this one. You can use a negative index. Okay, next one, you need to know about the negative index. So when we say negative index, okay, so when we talk about negative index, so when we have V of -1, it really means it is V of the length of V minus 1. Okay, so we say V minus 1, you will get 7. Okay, so let's try this one. So negative index you get as this. Okay, so let's try another one. Let's try print V minus 5. Okay, minus 5. So -1, -2, -3, -4, -5. -5 you get 3. So it's the same as you are talking about V of the length of V minus 5. So it's A minus 5, you get V of 3. V of 3, you get this one, right? So you get that. That's the negative indexing, okay? When you do slicing, sometimes you get negative indexing. Now, the question is, how can you reverse the array in a very easy way? Okay, so that's the point. So this one, I'm going to start in from -1 to the beginning of the array, and then jump by -1. Starting from this one, going backward, so the jumping index is jump by -1, going this way to the end of the array. Okay, so let's actually save all and print it. You will see this one is the reverse of it. Is that okay? That's how you use the slicing, okay? A few things is that, okay, let's review it one more time. 3 number is starting, ending, and jumping number, okay? 3 different things. Starting one always included, ending one always not included, okay? Jumping one is that every time when you advance, how many, how is the increment of the index, okay? So here you say nothing. You are starting from 0, ending the array, and then every time jump by 1. Default value, this jump is 1, okay? So this one you study from -1. -1 really means that the V then is -1. It's the last element, that's the 7. And then second one, I do not specify. That's actually to the end of the array. And the next one is actually go by -1. Go by -1 is from 7 to 6 to 5 to 4 to 3 to 2 to 1 to 0. Is that okay so far? So that one will give you the reverse. Okay. So if I want to have, say, 7, 5, 3, 1, that will reverse, but only odd numbers. So I would do print. Okay, here V -1 column -2. So this one I started from the last one.
5,
Jump by 2, jump by 2, jump by
3,
2.
1.
Okay, so that's how you perform slicing. Is that okay?
Yes.
So this is how you actually, when you do array, the slicing, how slicing works. Okay. Any questions so far?
No.
Okay. Anybody else question? Okay. So Tuesday and Friday, I don't teach you the course material. Okay. All of the course lecture, you need to watch the video that I pre-recorded. So Tuesday and Friday, my purpose is to review whatever question you have. Okay. So you need to watch the video in advance. Okay. And then I can answer your question. Okay. Today is an exception because today we are first time. So I try to teach you this linear algebra portion. Okay. Most of the time you need to watch the video first. And then on Tuesday and Friday, I give you the time for us to discuss no matter it's a homework or it's actually some concept in the textbook you don't understand. Okay. And the next one is the aggregates. You try to find the maximum, minimum, and sum. They are function, you can actually directly use it. Okay, so let's actually look at this different one. Okay, let me use another one called array 4. Okay. So this array 4, let's have an array. This one actually is, let me randomly do it, okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, this one is a list, right? And I say this one is actually np.array. You can put the list in there, but you can convert it back to array. So it's okay. Self-assignment is okay. Okay, so this one we create this one. And then let's do print. Okay. Print the maximum would be for common a dot max. Okay. Print minimum, okay. A dot min. Okay. Print sum, okay. Common a dot sum. Is that okay? Yes, you get maximum is 10, minimum is 1, sum is from 1 to 10 is 55. Okay. Any question? This one we call it aggregates. Okay, this one we call it aggregates. Okay. Okay, this one we call it aggregates. Okay. This one's aggregate. Then sometimes in Python we may need to do something called grouping of the parameter. Okay. Grouping of the parameter is not too hard. So for example, that I want to define average. Okay. So for example, I want to actually calculate the average of 1357, an arbitrary number of the data. Okay. Sometimes I may add another one 9. Okay, the length I don't know how long it is. Okay, let's do this one A5. Okay, 5 numbers average. So how can I design a function that actually take in a flexible number of the parameter? So this one we can use the star ARGS arguments. Okay, this argument will group the arguments into list. Okay, it's as good as that you do arguments equal to this 1, 3, 5, 7, 9. It's as good as that is. Okay, so here we do get this one, and we want to get the average, right? So we do sum equals to. Okay, here we do numpy.arrays. Okay, and then here we put ARGS. ARGS itself is a list. We convert it to an array, and that become an array. And at the end, we do calculate the sum, and we assign to sum. But this sum we don't need it. We just do return right away. Right, that would be your sum. And at the end, we want to get the average, so we say divide ARGS.length. No, sorry, it's not Java, so you use a length. And I will get the one nice solution to get the average number. Okay, so that's one nice solution. So that's actually print A5. Does that make sense? Okay, let me save it. Okay, it's a 5.0. Is it okay so far? This average is 5. Okay, I can create another one. This one called define. Okay, make array. Okay, this make array. Let me use the star ARGS again. Okay, this one I'll return. Okay, np.arrays and then ARGS. Okay. So here, let's see. Here, let's do ARR equals to make array of 1, 3, 5, 6, 2, 4. And then let's do print type of the ARR. Okay, and then let's print ARR. Okay. First, I type out the type of the sense that I make, and that will make an array of any arbitrary length that you want to have. Is okay? It's an ND array, and the array being made in this way. Okay? Is that okay so far? That's the grouping of a parameter. Grouping means that these different number you group them into a list. Into a list. Okay, and you can treat it like a list, no matter what you need to have. Okay? Okay, so this is aggregate. Okay, sometimes you might need that. Okay. Next one is the creative metric. Creative metric, you can put in this 2-dimensional array like this. Okay, that's one way you can do it. Okay, and you can put in the zeros. Remember, this 3-2 is shape. So 3 row, 2 column. You make a shape of 2 by 3, and everything is once. So typically we use this 0 more, okay? Because usually a lot of metric is initially like that, okay? So let's actually do metric number 1. So metric number 1, the py, okay? So here let's import a numpy as np. Okay. M equals numpy.zeros. So here I say 2 by 2. 2 by 2 is 2, 2. 2, 2. Okay, remember this one is a tuple. 2, 2 is a tuple. And tuple is the shape of the matrix. And the shape of matrix actually is what? Shape of matrix is your row and your number of columns. Okay. So after that, we do print by M. And that's wrong. You do get 2 by 2 all zero matrix. Okay. Does that make sense?
Mhm.
Yeah.
Yes.
So you can have 2 by 2 to whatever, and you can also use a random number to generate. Okay. And random number generate 0 to 1, 0 to 1, but not including 1. And to generate the non-zero one, to generate the non-zero one, I actually showed you a moment ago, okay, to use the Rx function that I show here, of given starting and ending range. Okay, so if you don't know how to do it, you kind of need to come back to here. All the simple code of the class, I'll send it by email, okay? So you'll get a copy of it. And I will also put where your course shell, I will put into the recorded session 2022. Okay, let me pick 2021 as example. The last year's discussion, I put it over here, the video that I recorded. Usually within a day, I post it here, okay? And there are slices, demo code. See, here I sometimes have the demo code. The demo code you can download from there, okay? The demo code you can download the demo code here, okay? So usually I will keep the demo code here. You can see the demo code I use in the class, okay? So same thing. I have the 2020, 2021. So this year I'm going to put into this 2022. So far, nothing, okay? Because today we only had session 1. After within a day, I try to process the video and I'm going to post it later, okay? I'm going to post it there. Okay, next one, we do have this 2D creation. That is okay. To set any data, I told you how to do it before, okay? So when you do addition, that would be the corresponding data's addition, okay? So 2 dimension is still doing that, okay? And you do have you can actually do a matrix plus a plus a vector. So if we row plus row plus row plus row, okay, it actually is something like this, okay. So when you have the matrix operate with vector, okay, it will be something like that. Okay, actually, California has an earthquake, okay? My desk is shaking. Okay, I'm sorry. We briefly have an earthquake. Okay, settle down now, okay? Sorry. Next one is the inner product. Inner product, you have a vector times a matrix. You do dot. You do DOT, that's inner product, okay? Inner product means that you have this row multiply column, 2 vector multiply inner product. Okay, so this one times this one. So basically your row 1, column 1, you get this number. Your row 1, column 2, you get this number. So a 1 by 3 data times 3 by 2 data, it becomes 1 by 2 data. Is that okay? Is that okay?
Yes.
If you operate a dot metric, okay. So this one so this is the dot metric, okay. So that's the dot product. You need to know about dot product. Okay, okay, this one I think is okay. Okay, matrix index. Matrix index is similar to the array index. It also allow the slicing. Okay, so the slicing rule we already talked about it. Matrix also had the aggregation, so you also can do the matrix maximum, minimum, and sum. That's also okay. This one I think is okay. You can do reshaping. Reshaping we teach you already. One important reshaping is transpose. Okay, transpose is more openly used. So you have the 3 by 2, you change it to 2 by 3. This is transpose. Let's look at this one. Okay. Let's look at this one. Let's go to the matrix number 1. So the 0 we generate already. So here that's actually to print. Okay. So here let me create another one that's actually have the A equals numpy that array, okay, of let's do 1, 2, 3, 4, 5, 6, 7, 8, okay. And this one, after I finish it, I say A equals numpy that reshape. Okay, I reshape it into a 2 by 4 matrix. Okay, so here you must put a tuple. Because the tuple, so we have 2 label of parentheses. Okay, there's nothing wrong. Okay, you put the shape. The shape parameter is a tuple. So tuple by itself need to have parentheses. Okay, so this is nothing wrong. After that, this A become a 2 by 4 matrix. Okay, so that's a print A. And I finished print A. Let's get the A's transpose will be A dot T. That is the transpose of A, and that's actually print out 18. Okay. In between, let me print this extra line. Something wrong. Okay, let's see. Reshape. Okay. I'm sorry. Let me take this one. Okay. Sorry. Maybe I'm wrong. It just take 2 numbers. Okay, let me check the reshape. Sorry, let me go back to the reshape part, okay? The reshape part, you have the shape reshape, we actually do 2, 3, okay? So here 1, 2, 3, 4, did I'm okay. So let me see what's wrong, okay? Trace back in reshape. Okay, line 6 in reshape. Line 6 reshape. Cannot reshape array of size 1 to size to reshape 4. Cannot reshape size 1 to reshape 4. I'm sorry.
1 by 2.
Here is A, okay. It's A's reshape. Yeah, I'm wrong. Okay. NumPy is not a data. Okay, I make it wrong. Okay. So here is actually is A need to reshape to 2 by 4. Okay. So A after that is actually this one, right? And I do transpose. So this one is the transpose of A. It's called A dot. A dot you do transpose. Okay. So that's the transpose. Okay, that's the transpose. Other than that, I think we are fine so far. Okay. So that's a transpose, and you can do reshape by yourself. Okay, and there are different slicing rule you need to look at. Okay. And after that, we still have a few things. Let's go over quickly. Okay, we are actually over time. So there are metric operation. You can read it by yourself. Okay, so basically, there's another thing called metric, but it's a metric already out of date. So I really suggest you just to do array. Okay, don't use this metric is older but array. Okay, they call it metric, but nowadays people just use array. Okay, and you do the similar things. Okay. Okay, so this one, okay, and you can also put this column format data to it. Okay, but I usually don't do this now. Other than that, it's okay. There are basic metric operation: addition, subtraction, division, and multiply. You can use. Okay, you can use addition, subtraction for two metric. So np.add, you can put two metric to do addition. Okay, you can put it in this way. Okay, and remember when you do multiply, it's actually element-wise multiply. Okay, if you want to do the multiply by matrix, saying that you want to do A, B, C, D, you want to do let's do S, Y, W, Z. Okay, you want to do the matrix operations multiplication this by this. Okay, and this by this, it actually is A at B. Okay, this multiply here, you propose element-wise multiplication. Element-wise multiplication means that A, B, C, D times S, Y, W, Z. You'll be A times A, get AX here. B times Y, you get BY here. CW and the DG here. Okay. So this multiply is different from this inner product, okay, in different metric operations. So that's something you need to know, okay? Okay, other than that, this metric operation. So we do have the star multiplication, okay? You do have star multiplication, and you have add multiplication. So this one is add multiplication to do metric multiplication. So that's the type of metric multiplication that we need, okay? And if you do the star multiplication, it's a per element multiplication. It's different, okay? So this one, your A times B, usually your matrix operation, you need to use A at B. This is a matrix multiplication, okay? And you have I2, this is eigenvalue. I2 means eigenvalue. So you have identity matrix. It actually is 1, 1, 0, 0. Okay, this is again identity matrix. Okay, so this one you write it down in this way. Okay, that's something we need to know. Transpose, I talked about it already. Okay, and here there's a function you can find a trace. Okay, norm is the norm of the matrix by the definition here. Okay, so you work on your week 1 homework, and if you have question, let me know. Okay, here we do also have the cross product for two metrics. Okay, this one in the later chapter maybe week 4 or 5, we may need it. Okay, we will teach you how to do cross product at that time. Okay, anyway, that's about it. Okay, some of the more advanced one, you have to look at it by yourself. Okay, any questions so far? No? Everybody so no question? Okay, if no question, today we are up to here. Okay, some of the advanced topic not related to week 1, I'm not going to cover it too hard. Okay, so we will do it maybe sometime later. And every Tuesday, Friday, same time, noon time, I would actually try to come here to discuss, okay, whatever question you have, okay? Anything you need? For students who don't know how to install the software, please let me know, okay? Again, let me actually give you my way of contact. My Facebook Messenger. If you want to send me a message, do HTTP, okay, /Facebook. This one I think is the fastest way to find me, okay, .com /Dr. Dr. Eric Chell. Okay, that's my Facebook site. Okay, just remember this. Facebook.com/ okay. Email, you can send me to echou@louisu.edu, okay. And you can also send me to echou 510. 510 is my area code at gmail.com. And usually I read this Gmail more often, okay? Because I seldom log into the Louis Yu account. And then my phone number is 510-304-9428 in case you want to talk to me. Okay? Any question?
Question about the XARM project.
Yeah.
Is that a web-based platform we'll be logging on to? We don't have to purchase the actual
No,
hardware.
you don't need. No need. It's just a video for you to watch.
Okay.
The term project, you can work on your own robot of your own choice. Okay. So you can buy whatever robot you want. If you want the $200, $300, $2,000, I'm fine. Anything you get. Or if you don't have the budget, you just want to do mathematical modeling, you just write Python code, I'm also fine. Because everybody's economical situation is different, okay? I cannot force you to just buy some $200 robot. That doesn't make sense, right? And we are an online course. So that one is actually a creative project. Try your best. And I guarantee you, we don't give more point to students who actually buy robot than those ones who don't buy, okay? We are not trying to sell anything. Is that okay?
It makes sense.
Also, one more thing I need to remind you, everything due, definitely due, no extension, December 18, Sunday night, 11:59 p.m. Your very last submission need to be arriving before that time. Anything after the Sunday night, after Friday of the last week, I'm not going to take it. Okay? But if you are late, I'm fine. Every week we have something due. You are late, I'm fine. I'll still grade them. Okay? But if you anything after December 18, Sunday night, 11:59, okay? I'm not going to take it because I need 1 day to tabulate your final grade. And then I need to send to the university Tuesday morning, 8 o'clock. That's a due time for me. Okay?
Okay. One more question.
Yes, go ahead.
A good beginner programming Python book. You know, I have C++ background. I've used Python in some of the classes, but you know, I'm proficient at a very, I guess, minimum level in Python. Can you recommend a really good book?
Can I recommend a good book? Yes, I can.
There's a lot of books out there, but a really good one that, speaks to the computer science sort of terminology.
Speak to the computer science knowledge. Okay, let me tell you, okay?
Maybe I missed it. I'm sorry.
Number one, you do not need to have a good book. You just need some good video.
Okay.
So let me see, okay? One moment. Let me give you something for free, okay? By the way, I'm also teaching Python, okay?
Okay.
So here I do teach Python. Let me pick a good one for you, okay? I'm sorry. That's my website, son, okay? Wait. Let me find one.
Welcome to EC Academy. This is the
sorry,
best
this is
computer
not
and information technology school.
Some
We provide educational services to accelerate
Okay, let me
your
give you
learning
this one,
process
okay?
for computer technologies.
Let me give you,
We
I'll
provide
post
the
the
best
link to the
on-site,
chat box.
online computer education. Our school uses the following way
One
to
moment,
help
okay,
you:
one moment. Let me post it in the chat box.
in person or online teaching
So
sessions.
here there's a
You may
playlist.
choose to meet our teacher in person or
Let me close
online.
it, okay?
The
There's
class
no
meetings can be in a term-based
So do you
course
see that?
or simply
Do you see that?
Yes.
In the
Yes.
chat box, okay? And that one is good. For a test
good.
book, if you want a test book, let me find a test book for you, okay? So this one called Jiang Vera, okay? That is for money, okay? Introduction to Python programming, third edition, PDF. Okay. There are tons of the PDF you can find. Is there, okay, I think this PDF drive. Okay, this one I think probably this one work. Okay, I cannot guarantee, but probably this one work. There are tons of the link you probably can have. Let me give you this one. Okay, this is a book you can use. But book I think take more longer time. Okay, book I think you take longer time to reach it. So this one I think maybe this one is better. You can search around, okay? I think there are some free one. You can download it, okay? You can download it. And the one you see right here, the one that I just give you, the link is a video that I teach some high school student using the book I talk about. Okay, that one actually, the one that I gave you, the link I gave you, that is, okay, let me give you another one. I do teach 2 sessions this year. This one, true beginner one. Okay, and also if you have any question you want to bring up for Python, you are welcome in Tuesday, Friday. And if you want to do coding practice, okay, you can do coding back Python. This one, after you reading it, you can actually practice it over here, okay? It's a self-grading system, so you can improve your Python a lot. My purpose of teaching you this kind of Python modeling and math is because the optimal goal is to help you to be able to pass some interview in the future. You know what I'm saying?
Mm-hmm. Yes.
That's the optimal goal. I mean, not a lot of people will really have the chance to build a robot, but everybody will have the chance to do some interview. Okay, so coding still be very important. Okay, so here we do have a Python coding bed, and the Python coding bed is a self-training site. Okay, and you can use it to review. But when you do this one, remember, finish warm-up 1, and then level 1, string listed logic. And then you do warm-up 2, and then logic 2, okay?
Okay.
And if you bump into some problem, it's okay, you bring up in the Tuesday, Friday discussion. I'll help you, okay? Is that okay?
Yes. That's very helpful. Thank you.
I helped many students before, okay? Any other question? Okay, no question. That's it for today, okay? Thank you. Bye-bye. See you on
Thank
Friday,
you.
okay?
Bye.
Bye-bye.